Okay, today we are going to discuss exercise 13.3 in surface area and volume. First problem, a metallic sphere of radius 4.2 cm. A metallic sphere. So sphere shape is given, metallic. So volume. So radius given. Is melted and recast into the shape of a cylinder of radius 6 cm. So cylinder shape we need to form. Its radius 6 cm. Find the height of the cylinder. So we need to find the height. Remember, in that sphere we have only one unknown data, that is radius. So it's given. But in the shape of cylinder we have radius and height. There is two unknown data. One radius is given, another unknown data h we need to find. But their volumes are equal, that is sphere and cylinder volumes are equal, so that we are going to equate the volumes of cylinder and sphere. Using this we are going to find the unknown data. So sphere into cylinder we need to find. In sphere radius 4.2 cm, that is r 4.2. in cylinder radius 6 cm, we are need to give the difference, so that r dash equal to 6 cm. Now volume of sphere is 4 by 3 pi r cube and the volume of cylinder pi r squared h. We need to give the difference, that's why r dash squared h. Sphere melted and recast into the shape of a cylinder. Okay, that is volume of sphere is equivalent to volume of cylinder. Volume of sphere 4 by 3 pi r cube, here pi r squared h. So we need to swipe the value because we need to find h. So pi and pi we can cancel. So r dash squared into h is equivalent to 4 by 3 r cube. So now we need h only, because this one only we need to find. So h equal to 4 by 3 r cube divided by r dash square. Their radius are different, that's why we need to give the difference, or here r dash. So 4 by 3 into this r value 4.2, so power 3. Here 6, so 6 square. So substitute 4.2 power 3 means 4.2, 4.2, 4.2. Here 3 and 6 both are denominator, we need to multiply. Or 6 square divided by 1, it's reciprocal 1 by 6, so that it's in denominator. 6 it's in denominator. So 6 square, that's a 6 into 6. Just cancel 6 and 4.2, or 3 into 4.2, or 6 into 4.2, like that. Just to cancel, we can get this 1.4, 0.7, 0.7, we get the product 2.744 centimeter, that is one dimension, so centimeter. So what we needed to understand, we are going to recast from sphere to cylinder. Here unknown value r given, radius given, here unknown value r and h. R value given, we need to find h value by equating the volume of two things, that is sphere and cylinder. Okay, similarly second problem, a metallic sphere of spheres of radius 6 cm, 8 cm and 10 cm. So three spheres, their radius, that is radius are 6 cm, 8 cm and 10 cm, are melted to form a single solid sphere. Find the radius of the resulting sphere. So they are asking not the volume, they are asking only the radius. So we are going to reform into new sphere. That new sphere radius only we need to find, that radius. So we are not going to find that volume, but that three volumes are equivalent to volume of the new sphere. So we are going to equate the sum of their volumes, that is sphere 1, sphere 2, sphere 3 volumes and the new sphere volume. Using this we are going to find the unknown value r of the new sphere. So sphere 1 radius 6 cm, so r1 6 cm. We need to give the difference. That's r1, r2, r3. That is r1 6 cm, r2 8 cm, r3 10 cm. Now volume of sphere equal to 4 by 3 pi r cube. We need to add all the sphere volume. So volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3 equal to volume of new sphere. So all the sphere volume 4 by 3 pi r cube. But anyway, we need to give the difference. That's why r1 power 3, r2 power 3, r3 power 3. Here only radius, that is r power 3, 4 by 3 pi r power 3. So 4 by 3 into pi is a common. So here r1 power 3, r2 power 3, r3 power 3 we can take equivalent to 4 by 3 pi r cube. Just cancel 4 by 3 and pi. So r1 power 3 plus r2 power 3 plus r3 power 3 equal to r power 3. So there is 6 power 3, 8 power 3, 10 power 3 r cube. So r power 3 equal to this value. So r 6 power 3 216, 8 power 3 512, 10 power 3 1000. So 1728, it's a perfect cube number. We need to give the cube root of 1728, that is 1728 to cube root 12. So r value 12 centimeter. Or using a prime factorization we can find by using the 3 pairs. So 1078 prime factorization, divide by 2, divide by 2, divide by 2 and divide by 3. From 1 3 shed we can get 2. This 3 we can get 2. This 3 we can get 2. This 3 we can get 3. So that product 2 into 2 into 3 12. So like that we can find the radius. So recall, here we are studying the combination of particular shapes. So don't find separate volumes, that is sphere 1 volume, sphere 2 volume and sphere 3 volume, and don't find their 4 by 3 pi r cube, that is new sphere volume, and don't find r value. So it's a lengthiest process. Always try to use the common form. Using this we can find the easiest answer. So you can find by your own way, but here just understand common things means we can cancel 4 by 3 and pi. After that they are in perfect cube number, so we can find easily. Otherwise we need to find 3 sphere and volume answer, and using this addition we need to equivalent with 4 by 3 pi r cube. After the cancellation we can get this answer. Okay. Next, third problem. A 20 meter deep well with diameter 7 meter is dug, and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So it's a cylindrical form, and the next one is nothing but a cuboid form. In the cylindrical form, height is given 20 meter and the diameter given 7 meter. So here it find the height, but the flat form 22 meter by 14 meter. In that cuboid, length 22 meter and breadth 14 meter. Just to find the height. So length, breadth and height, that is cuboid. So just understand, just a volume of cylinder we are going to just reform into the cuboid. So that is the given to the platform. By means product, L into B into H, that is product is by. So 22 into 14, 22 into 14, this is the meaning, right? Now cylinder height 20 meter, diameter 7 meter means radius 7 by 2 meter, and a cuboid we are going to consider length 22 meter, breadth 14 meter, and the height we need to find. So volume of platform nothing but volume of well. So volume of cuboid is volume of cylinder. So LB is equal to pi r squared H. So LB we know that 22 14 and H we need to find. So pi value 22 divided by 7, r value is 1 by 2 and H value 20. Substitute, and 7 by 2 whole square nothing but 7 by 2 into 7 by 2. Now just H is equal to the product 22 into 14 right side in denominator. So into 1 by 22 into 1 by 14. So after this cancellation we can get 2.5. How it's possible? 22 22 we can cancel, 7 7 we can cancel, 14 and 7 we can cancel. Like that we are going to cancel. Finally we can get H value 2.5. Height of the platform 2.5 meter. So here just cylinder height and radius given, so we can find the volume of cylinder. But here that H value we need to find, that is unknown value H. Length and breadth given. Using this we are going to find that H value. So their volumes are equal because a well of diameter is 1 meter dug and the earth from digging is evenly spread out, so their volume equal. So that's why we need to equate with your cuboid and cylinder volume. Okay. Come to fourth problem. A well of diameter 3 meter is dug 14 meter deep. The earth taken out of it has been spread evenly around it in the shape of a circular ring of width 4 meter to form an embankment. Find the height of the embankment. So a well has a diameter 3 meter and height 14 meter. So that is cylindrical shape. Next we are going to form a embankment. What is meant by embankment? So we are going to use some height. Using this height we are going to form some platform, that is a circular platform of your well. So definitely just this is one nothing but a hollow cylindrical shape. In that hollow cylindrical shape, first 3 meter is nothing but a diameter, so radius 1.5 meter, and width of the embankment is 4 meter. So in that circle, bigger radius is nothing but here smaller one 1.5, their width 4, so totally 5.5. So this one is 5.5. Say now we need to find the hollow cylinder volume. How to find the hollow cylinder volume? Just recall. Now suppose this is the two circle, one is small circle, another one bigger circle. We need to find the shaded region. How can we find? Volume of this bigger circle minus volume of small circle is nothing but shaded region. So this capital R bigger radius, small radius means areas of the area of a shaded region nothing but pi capital R square minus pi small r square, that is pi into capital R square minus small r square. Like that we are going to find the volume of hollow cylindrical shape. So in that hollow cylindrical shape, capital R and small r given. Okay. Now the data. In that cylindrical height 14 centimeter, 14 meter, diameter 3, that is radius 1.5. Both are cylindrical form. We need to give the difference. Just in any one give r dash and h dash. Here cylinder h dash and r value r dash. So embankment width 4 meter. So bigger radius. So bigger radius means this one small radius 1.5, bigger radius 1.5 plus 4, so 5.5 meter. Smaller radius already 1.5 meter. Now their volumes are equal. So the volume embankment pi into capital R squared h minus pi small r squared h equal to pi r dash squared into h dash. That is pi r squared h. We need to give the difference of this r, that's r dash. Here pi and h are common, so pi into capital R squared minus small r squared into h. This is the volume of hollow cylindrical shape. Substitute. Here capital R value 5.5, small r value 1.5. Substitute. The right side r dash value 1.5, h dash value 14. Now a squared minus b squared identity, we know that using this a squared minus b squared is nothing but a plus b into a minus b. Using this identity, this one a value, that is 5.5, b value 1.5, so addition 5.5 plus 1.5, subtraction 5.5 minus 1.5 into h equal to 1.5 square into 14. So this addition 5.5 plus 1.5 7, subtraction 4 into h. So right side h equal to 1.5 into 14 divided by 7 into 4. Just a cancellation. After this we can get h value 1.125 meter. So cancellation, just 4, 7, all are cancel easy. So we can cancel 7 and 14 2 times. After 2 this 2 we can cancel, 1.5 is so 0.75. After this product we can get, so height of the embankment is nothing but 1.125. so height of this embankment, this height, so height is nothing but the height of embankment above the ground level, how much its height, how much its height in that particular cylinder, so that height from the embankment. So we need to see the well by using the embankment, so that's why they are used embankment. So just in this problem, hollow cylindrical shape volume we have, so that's why we are going to use this thing. Okay, similarly we are going to study fifth problem. A container shaped like a right circular cylinder having diameter 12 cm and height 15 cm is full of ice cream. It's full of ice cream. The ice cream is filled into cones of height 12 cm. We need to fill the cone, the height 12 cm and the diameter 6 cm, having a hemispherical shape on the top, having the hemispherical shape on the top. So cone, after that in above we have hemispherical. Okay. Find the number of such cones which can be filled with ice cream. So we need to find the number of cones. So what do you want to identify? This one is bigger one. This is a cone. In this cone and hemisphere, it's a combined shape. So volume of cone and volume of hemisphere we need to find. Okay, using this, how many such cones? Just recall here, suppose capacity of the cylinder 50 liter. Our capacity of this type of combined shape is suppose 2 liter. Then how many cones, such a cones needed to fill this ice cream means we are going to divide their capacity. That means we need to divide their volumes. So volume of cylinder divided by volume of such combination. So 50 liter divided by 2 liter, nothing but 25. So 25 such a cones needed. So we need to divide this volume by this volume. So this is a single shape, so this cylinder. This is a combined shape, that is cone and hemisphere, right? Now cylinder height 15 cm, radius 6 cm, that is diameter 12 cm, radius 6 cm. In cone height, so 12 cm, diameter 6 cm, so we need to give the difference, that's why h dash and r dash. So radius 3 cm. In the same way hemisphere diameter 6 cm, so radius 3 cm. Now volume of cylinder is nothing but pi r squared h, substitute 6 and 15. Now volume of combined of cone and hemisphere, because we need this total volume, the combined form. So volume of cone and hemisphere is nothing but volume of cone plus volume of hemisphere. So 1 by 3 pi r squared h, so we need to give the difference, that's why r dash. Here 2 by 3 pi r dash power 3. Just remember here pi r dash square, here r dash power 3, one more r extra, that is pi r dash squared into r dash. So here 2 r dash, here also 3 r dash. We can take 2 r dash in outside, that is r dash into r dash. So pi r dash squared into 1 by 3 h, here 2 by 3 extra term r dash. So substitute r dash 3 and h value 12. So 3 and 12 we can cancel, as that is 4. This 3 and 3 we can cancel, that is 2. 4 plus 2 6. So this one, don't multiply, don't substitute pi value, because we are going to divide one volume by another volume, we can cancel pi value. So number of such cones equal to volume of cylinder divided by volume of cone, that is cone and hemisphere combined form. So just we can cancel pi. So recall, we already discussed, don't find that volume separately, because we need to find the combined form. In this form, that cancellation easy, right? So pi we can cancel here, 6 squared into 15, so 6 into 6 into 15, 3 squared into 6, 3 into 3 into 6. After this cancellation we can get the number 5. So number of such cones are 5. So what we want to understand this, we need to fill the ice cream. So volume of cylinder is equal to volume of the combined shape of cone and hemisphere. So divide one volume by another volume, so we can get the number of such cones. So be careful by substituting the different radius values, because here R value radius 6 cm, here R value 3 cm. Don't confuse with this 6. Like that, you need to be careful about this R, here R dash, no. So that's why we are given the differences. So H dash or R dash. Using this we can find. This is for our convenient only, we given as R dash. So you need to identify by your own way of answer. Okay. Similarly, next problem. How many silver coins? We have coins. We need to find the number of coins. 1.75 centimeter in diameter and of thickness 2 millimeter. Must be melted to form a cuboid of dimension 5.5 by 10 by 3.5 lbh. So just recall, this height is a smaller one of our coin. That is, it's a cylinder. So cylindrical volume into cuboidal volume. So here we needed to form such a coins, or number of coins we are going to form. Number of coins possible to form by using the volume of cuboid. So cuboid dimensions LBH 5.5, 10 and 3.5 given. In that cylinder, diameter is given. So coin, it's a cylindrical shape, diameter 1.75, that is R value 1.75 divided by 2. Thickness. So thickness means it's nothing but height. So height 2 millimeter. We have all the one in centimeter form, because centimeter given. So we need to convert our millimeter into centimeter. Here 1 centimeter equal to 10 millimeter. That is 1 millimeter equal to 1 by 10 centimeter. We need to divide here. So here 2 millimeter means 2 millimeter equal to 2 by 10 centimeter. That is thickness. That is height. Height 2 by 10 centimeter. Just divide by 10 of your given millimeter value to convert into centimeter. Now cuboid length breadth given. So number of coins. So we are going to find the number of coins. So already we discussed, we need to find the number of coins means we need to find their volume, and finally we need to divide a bigger volume by smaller volume. We can get such a number of coins. So volume of cuboid is bigger, so volume of cylinder is smaller, because how many silver coins to form by using this dimension. So volume of cuboid divided by volume of cylinder. So 5.5, 10, 3.5 given lbh. Here pi r squared value 22 divided by 7, 1.75 by 2. Here into 1.7 by 2 into 2 by 10. Okay. Here 7 we can convert into numerator. 2, 10 also we can convert into numerator. Here 22 and 5.5 we can cancel by 11. So 2 here, just careful, 0.5. Here 1.75 is nothing but 3.5 divided by 2. So 1.75 into 2 is 3.5. We can cancel. So 1.75, 1.75, that is 4 times of 1.75 is nothing but 7. Because 1.75 into 2 is 3.5, 3.5 into 2 is 7. So we can cancel this as 4. After this product, 0.5, 10, 4, 2, 10, we can get number of coins 400. Okay, so this cancellation, be careful, because 1.75 into 2, 3.5, 1.75 into 4 is 7. Using this cancellation, we can get the number of coins 400. So volume of bigger cuboid and volume of smaller, that is coin volume, just divide. This is the idea to solve this problem. Similarly, next problem, a cylindrical bucket 32 cm height and with radius base 18 cm, height 32 cm, radius 18 cm, is filled with sand, that is volume. This bucket is emptied on the ground on a conical heap. So we are going to empty this bucket we are going to form a conical form, that is cone form. If the height of the conical heap, height is 24 centimeter, find the radius and the slant height of the heap. So find the radius. So the question is find the radius, this length. So now just to recall, we are going to equivalent with our volumes. The volume of cylinder is equivalent to volume of this cone. Here cylinder data value given, but here data are H and L. But in their volume we have only H and R. Using this we can find. So cylindrical shape, height 32, radius 18 cm. Cone shape, we need to give the difference. Let's say H dash 24 cm, R dash we need to find. So volume of cone equal to volume of cylinder 1 by 3 pi R dash square H into H dash. Here pi R square H. Substitute the value. Here pi we can cancel. 3 and 24 as 8. So 8 we can write in the right hand side. 18 into 18 into 4 divided by 8 into 32. R dash squared is nothing but 18 into 18 into 4. Be careful, we need to find only R value. So we already know that how to find that square root of certain value. Already 18 into 18 given. So if you are going to find that square root of this number 18 into 18 into 4. 18 into 18 we can take outside. Plus into 4 we given, no, we can write as 18 into 18 into 2 into 2. Already 4 is a perfect square number. So 18 into 2, this pair 18, this pair 2, so 36. Or by using prime factorization you can find the square root of the number. So easiest one already is 18 into 18. 4 we can cancel, no, that is already perfect square number. Just cancel, form the R dash value. So minimize the steps and also minimize the simplifications. So don't find this value separately. Already I insist you once again, so don't use 22 divided by 7. After this cancellation we can get only decimal value. Not possible to equate with your things, not possible to easily find the particular answer. So before solving this type of problem, try to write the combined answer form. They are equal, no, so we equate. Pi we can cancel, like that's all. Next we need to find slant height. So already in right angle triangle, hypotenuse square is equal to sum of the squares of other two sides. This is L value, this is H value, this is R value. So L squared equal to L equal to square root of H square plus R square. So 24 square plus 36 square. So here also don't expand 24 and 36. So because we are going to take an outside. So here 24 also multiply 12 and 36 also multiply 12. 12 we can consider as a common number. We can consider 12. So 24 we can write 12 into 2. This 24 we can write 12 into 2. This 36 we can write 12 into 3. This 36 we can write 12 into 3. So here 12 into 12 we can take outside. So 12 into 12. Remaining this 2 into 2. So 4. 12 into 12. So remaining 3 3s are 9. So 12 into 12 we can take outside. That is one pair. So 12. Remaining 4 plus 9 13. 12 root 13. Otherwise we need to expand and we need to divide by using the prime factorization. We need to count, we need to take the common number and finally write the answer. Using the prime factorization also we can find, but this is the easiest one. Just to study this type of answer also. Okay. So now the question is, we need to recast into the shape of a cone. Using this find R value, unknown value R. So we need to find. Okay. Similarly, next problem. Water in a canal 6 meter wide and 1.5 meter deep. So they are wide. That we are going to give how lengthiest one of the river, that is wide is given, and how it's deep, that deep also given 1.5 meter. Is flowing with the speed 10 kilometer per hour. Per hour the speed is given 10. Okay. How much area will it irrigate in 30 minutes, that is half an hour, if 8 centimeter of standing water is needed? So here just to recall, standing order is given, area is given, that is nothing but cuboid. So first one also canal, it's also nothing but cuboid. So cuboid into cuboid. So bigger one to smaller one. We need to divide one bigger volume into smaller volume. So bigger volume is first one canal, and the smaller volume, that in area irrigation, no, it's nothing but cuboid. So we need to divide the bigger one by smaller one, we can get just that area of irrigation. The idea is using the two cuboidal form. Okay, here just nothing but length 10 kilometer per hour. So speed nothing but distance divided by time. So distance, speed into time. So that is speed here given 10 kilometer. We need to find the distance now, that is distance equal to speed 10 kilometer per hour. Here remaining data is all in meter. So we need to convert, that is distance, that is length. In 1 hour it covers the length 10 kilometer, that is length. Remaining breadth and height is given as 6 meter and 1.5 meter. So we are going to consider this one as a length. So the length we need to convert into meter, just multiply by 1000. So 10,000 meter per hour. Its length 10,000 meter per hour. So that is length, breadth and height. In that length 10, breadth 1.5 and 6 meter, height 1.5. We can change this one also, but here width and deep is given, so we can use this one because cuboid we know that product. Then area of irrigation, it's also cuboid, some standing order and area. So here LBH, in that LB it's nothing but area, or BH nothing but area, or HL is nothing but area. So area means in 2 dimension, volume means it's in 3 dimension. So here L does LBH, here H, that is standing order given, height is given, so we need to give the difference now, that's why H dash. H dash equal to 8 centimeter. LB is area of the rectangle, that is area of irrigation. So just area of the irrigation means in one side view it indicates definitely area. So one side of the cuboid, we are going to look out that cuboid is nothing but one side area. So here area indicates LB, that is L dash B dash. So question is L dash B dash. Okay, in 30 minutes we need to convert into hour, means 30 by 60 per hour, 60 minutes. So 1 by 2 hour, 30 minutes it's half an hour, that's why. Now area of irrigation equal to volume of canal. So area of irrigation LB dash H dash L dash B dash H dash equal to LB, guys. Substitute this value, L dash B dash, its area of irrigation. So remaining here recall 8 centimeter we need to convert into meter. So 8 by 100 meter, because for 1 meter 100 centimeter. So right hand side just here product 100 divided by 8. So we can cancel easily. For 2 table it's 3, here 4. For 4 table here 25. So after this product we can get this number, meter square, because of area meter square per hour. Now the question is area of irrigation in 30 minutes. So area of irrigation in 30 minutes equal to meter square per hour, no. So half an hour means we need to multiply by half. So half into this one. So this is the meter square. Now we need to give that bigger number, no. So that's why we are going to convert into smaller number by using the hectare form. For 1 hectare we have 10,000 meter square. So divide by 10,000 means we can get 56.25 hectare. So area of irrigation 56.25 hectare, or this number in meter square. It's in half an hour. Okay. So understand. So just to convert to such type of speed given means convert into distance. Just to multiply or use directly this number. Kilometer given, convert into meter by multiplying 1000. Volume of cuboid into volume of Another given area of irrigation nothing but area L dash into B dash combined form is the question. Don't just multiply length or multiply the product of length and breadth is the area of irrigation. That is L into B of question. So L into B, don't confuse this one. Area of irrigation is area LB. So keep it up LB in left side, that is area. Remaining all are in right side. All the numbers we know that, just substitute and find. Similarly, a farmer connects a pipe of internal diameter 20 cm from a canal into a cylindrical tank in her field. So recall pipe, it's a cylinder shape. So pipe cylinder shape which is 10 meter in diameter. Which one? The canal. It is 10 meter in diameter and 2 meter deep. It's also cylindrical shape, cylindrical tank. If water flows through the pipe at the rate of 3 km per hour, if water flows at the rate of 3 km per hour. So in the previous problem, the same type of things we discussed. So flow, that is speed, is given. If water flow, this means in how much time will the tank be filled? In how much time the tank be filled? So canal into tank using the pipe. Now the bigger volume is the tank, smaller volume is the pipe. So volume of a tank divided by volume of a pipe. This one only we need to find. So volume of now just recall pipe, that is cylindrical shape. So diameter 20 centimeter. So 2 are equal to 20 centimeter, r equal to 10 centimeter. Remaining data all are given meter. So we need to convert into meter, divide by 100 for 1 meter 100 centimeter. Just 1 by 10 meter. Speed 3 km per hour. So distance equal speed into time. So 3, that is per hour, that is 3 km, that is 3000 meter. So nothing but radius and height, that is cylindrical shape. So volume of cylinder is the flow rate is given, means we can use the volume. So, okay. In the cylindrical type capacity you need to find, that's a diameter given 10 meter and height 2 meter. So radius 5 meter, height 2 meter. So time taken means, it fills half an hour, 1 hour, 2 hour. That is it going to give. So it have the capacity 2 times of the pipe. It have the capacity 3 times of the pipe. That is the time taken. So volume of a bigger one divided by volume of smaller one. So time taken is nothing but volume of cylinder pi r square h divided by pi r square dash square h. So here 5 squared into 2. Here r dash squared 1 by 10. So 1 by 10 whole squared into 3000. So 1 by 10 into 1 by 10. So 3000 zeros we can cancel. So 30. So for this 30 and 5. So 6 and 6 and 2 3. That is 5 by 3. So 5 by 3. Time taken to fill the tank is 5 by 3 per hour, because we discussed all those things per hour. We can give the answer, whole number answer in minutes. Why? Per hour, or for 1 hour 60 minutes. So 5 by 3 into 60 minutes, that is 100 minutes. So this question idea, volume of cylinder, we need to find the pipe. The flow rate, the speed is given 3 km. That is height we are going to find. Radius automatically we can use. Convert into the another that is uniform form, uniform meter. Another one, tank also cylindrical form. So time taken is nothing but their volumes division. So volume of bigger one divided by volume of smaller one. Using this we can find their volume. Thank you.